Alright, so welcome back to part 2 of 2.8. Remember where we left off here. We wanted to figure out, first of all, if this function is one-to-one, and it is because it passes that horizontal line test. So, in order to find the inverse, remember our first step is to replace f of x with y. Okay, and then switch all my y's and x's. Now, solve for y. Add the 5. Divide by 2. And then to get rid of, just like to get rid of a x squared or a squared term, I take the square root. To get rid of a cube, or cubic, I take the cube root of both sides. So, y equals the cube root of x plus 5 over 2. Last step, f inverse of x equals the cube root of x plus 5 over 2. How about that? That's pretty neat. Here we go. Let's go on to some more. Wow. Here we go. We got to check. Again, we got to check the horizontal line test. Think about the square root function. Okay, the square root function is going to look, with the plus 2, it'll look something like this. All right, that function is one-to-one because it passes that horizontal line test. All right, which we'll talk about a little bit more in the next one. All right, so to find the inverse, remember we're going to replace g of x with y. What I want you to do is pause the video, try this one on your own, then watch my work. Go. Pause it. Pause it. Pause it. So here's my work for finding the inverse of g of x, okay? But now we need to have a little discussion, okay, first about this, all right? Our original function passed the horizontal line test, all right? But if you think about x squared minus 2, that's going to look like this, right? Shifted down 2. Okay, this function does not pass the vertical line test, all right? Technically, when I so when I try to, look at my horizontal line test, or when I input this and take the composition of this function, so I'm going to try that first of all to see if I get x. All right, so I'm going to plug in x squared minus 2 back into my original function here for x. So I have the square root of x squared minus 2 plus 2. Well, these cancel. All right, and I'm left over with the square root of x squared. Well, the square root of x squared gives me plus positive x or negative x. All right, so I want to think about this. Okay, well, do I want the positive x or my negative x? If you look here, forget about this line for a second. If you look at our original, all right, our original function is positive. Okay, if our original function is positive, that tells me that I'm going to want to look at the positive component of my graph, all right, or the positive side of my graph. Because if I look at this positive side of my graph, okay, and disregard the negative, well, the positive side will actually be a better reflection over the line y equals x for my inverse, okay? So I throw out, oh, that's not what I'm looking for. So I don't want any negative numbers here, because if I think about it graphically, that the reflection of our negative portion of our x squared minus 2 graph, or of our parabola, does not reflect over that line. So this is my inverse with the restriction that x must be greater than or equal to 0. X must be positive, because my original function was positive as well. All right, that's a little restriction for you, okay? This one as well. All right, let's talk about this one too. This function here, x squared minus 4, is going to look something like this, right? Well, that does not pass our horizontal line test either, okay? So we need to set some restrictions on this graph, all right? Some restrictions on this. We can do one of two things. We can either look at it look at our function where x is greater than or equal to 4. Or we can take the inverse. Whoops. Let's try that again, maybe. Maybe it'll work better this time. Where x is less than or equal to 4. So if I stick those parameters while I'm taking the inverse, or restrictions, excuse me, then I'm able to take the inverse of this graph, okay? Because then I'm only looking at one piece, where this one piece is one-to-one. All right, we're only, for every output, there's only one input on this purple line. If I think about the red line, for every output, there's only one input for that red line as well. So what I want to do, I'm going to deal with when x is greater than or equal to 4 first. So I'm going to say y equals x minus 4 squared. Switch x with y. But when I do this, I want to bring down my restriction. X must be greater than or equal to 4. Once I switch x with y now, replace my x's with my y's, now I still want to switch my x with my y here as well. So y must be greater than or equal to 4 now. Okay? Because remember, the domain of your function is the range of your inverse. Alright? So our domain becomes our range still. Okay? So then we continue to perform our operations. Alright? Square root both sides. Square root of x equals y minus 4, where y is greater than or equal to 4. Okay? Or excuse me, let's call it plus or minus. We'll circle back to that one. Okay? And then I add the 4 to the other side. X, the square root of x plus 4 equals y. So, with y greater than or equal to 4. Lastly, is this g? Yeah, g inverse of x equals the square root of x plus 4 with y greater than or equal to 4. Okay? And this is the positive, our positive, right? Because because y is greater than or equal to 4, we're looking at the positive values. All right, remember when I put that plus or minus out here, there was for a reason for that. Okay, so we're looking at the positive values in this inverse. All right, if I want to take the inverse where y is less than or equal to 4, okay, my inverse would look like this. Let's just extend this a little bit. There we go. I'd have g inverse of x equals the negative square root of x plus 4, where y is less than or equal to 4. Okay, where there's y. Sorry about that. All right, so we need to have this negative here because we want to be taking something away from 4 when y is less than or equal to 4. Okay? Let's keep going. Verify by the composition that g of x and f of x are inverses. So what I want you to do, we're going to do a composition of functions. I want you to find f of g of x and g of f of x. Okay, so go ahead, pause the video, do that on your own, and we'll check our work. All right, so check your work here. You'll see that if I find f of g of x and g of f of x, that my result is x. So these functions are in fact inverses. If you also, just want a quick little sidebar here, you can also think of this as a linear function since we're dividing this binomial by a single term by a monomial. So I could think about this as a 1/3 x minus 1/3 as well, if you like thinking these in terms of a linear sense. Okay, keeping it consistent. All right, that concludes Unit 2. It's a sad day today. Sorry, but we'll see you back in another unit.